Wise Guys Wednesday, everybody.
Why?
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 Paul Kwiat from the U of I Physics Department is with us now with some various props as
Stuff,
usual.
yes.
What do we have today?
Yeah, it's a little, it's the only thing I can handle. So this is a two-parter, actually.
Oh,
yes?
Yeah, so
exciting.
everything we're going to do today, probably people maybe already know, they've already heard before, but it's okay. It's going to set us up for next week for
a Halloween spectacular.
Most awesome, spectacular.
Very excited about that.
Spectacular.
Right, so
Very
we're going to talk about sound today. And sound is a wave. It's a pressure wave. So for example, if I hit this tuning fork here, what's happening is that this is vibrating as the metal is moving through the air. It's compressing the air, and then it moves away, and so I get the air is compressed, and then that moves along, and then it's compressed, rarefied, so I get this
Like a wave.
Exactly
And
like
you are wearing a musical bow tie. I'd like to point out Paul is always secretly dressed in the theme. So
subliminal messages.
Yeah, subliminal messaging.
Exactly. So if we want to make a louder sound, then we want to have a bigger pressure difference between those compressed and other airs. And I have a little graphic that I just put up here or sent along.
Oh, let's pray on that.
See if that goes.
There you go.
Great. So we've got this wave, and what we're concerned with today is actually how do you change the pitch of a wave, or what it sounds like to you. And there's a relationship that applies to any wave at all, which is that the speed of the wave is the wavelength times the frequency. The wavelength is the distance between the two crests, so the two troughs of the wave, and the frequency is just how many times it oscillates a second. So like a middle C is 262 times a second.
I feel like I'm back in class.
Okay, well, we are done with everything we need. So the whole thing is the frequency is the speed divided by the wavelength. So in many cases, the wavelength is set. So if we want to have a short wavelength, that will give us a high frequency. If we have a long wavelength, that will give us a low frequency or a low pitch. And many cases in many instruments, the wavelength is set just by the size of the thing we're dealing with. So this is just an ordinary plastic tube. There's nothing inside it. You can verify, right?
Verified.
And so that makes a particular sound. And this is a shorter one, so is the sound going to be higher or lower? Wavelength is longer. Good job. You pass.
Woo!
If we look at our tuning forks, this is a big tuning fork, so this is going to be a relatively low pitch. And if instead I take one of these,
really rattles your head.
then it's going to be a much higher pitch just because of the fact that it's shorter.
Yeah.
And in fact, you can make an instrument out of this then. So this is how this little xylophone works. These are, again, just empty tubes. And just depending on which one you hit, the longer the tube, the lower the pitch. So
that was fast. You did that really fast.
Yeah, I've been practicing hard on that. So the same thing is true, for example, in a guitar. So this is not a real guitar, but it does plink like a real guitar. When you move your fingers up and you make the string shorter, then that's a shorter wavelength, so then the pitch goes up. So that's how you can control that. It's the same thing why little kids have higher voices, because the vocal cords are a lot shorter than adult vocal cords.
A lot shorter, so the wavelength is a lot.
The wavelength is shorter, and therefore the pitch goes up. So the other way that you can change the pitch, we said that the frequency was equal to the speed over the wavelength. So if you can make the speed of the wave change, then that will also change the pitch. And that's what happens when you tune a guitar, when you increase the tension on the string. So I'm just going to pluck this one here and tighten this.
I know.
As I increase the tension,
Pitch is going up.
Yes, the frequency of the oscillation on the string goes up. So I'm not changing the overall length here, because the length is just fixed by whatever the two endpoints are. But by increasing the tension, I increase the velocity. When I increase the velocity, I increase the pitch. And that is how you can tune a guitar.
Very good.
Oh, Mick Jagger.
So this
live in studio.
Do you play the guitar?
Maybe this one, yeah, sure.
I'll play the tuning fork. I'll stick with
great.
this.
Sounds good. So this is all going to set us up for next week, which is going to be the most awesome Wise Guy
I am
I've ever done.
scared and thrilled.
It's going to be amazing. I will risk life and limb to bring you the most amazing demo.
You heard it here first.
Challenge accepted.
Okay.
Life
Next
and limb.
Wednesday.
Great.
Spooktacular. We have a spectacular episode planned for you guys too, so it'll be a lot of fun.
Great. Looking forward to it.
Thanks, Paul. If you guys have questions you'd like to ask Paul, Nadia, Stepa, Matt, who am I missing? Any of them?
Yes, Jeff Filipino.
Jeff. Sorry, Jeff. I knew it.
The entire U of I Physics Department.
Basically, anybody, if you guys want to have questions to them, let us know on Facebook, topics. You guys are always looking for new topics.
Always looking for new topics.
All right, cool.
Sounds good.
We'll see you next week.
Bye.
We'll be right back with more of the morning show.
I knew you were going to do that. I knew it was coming.